Abhimanyu Singh, working as an assistant professor in mechanical engineering department in SIRTS. Today I will give a brief lecture on heat engine and refrigerator. These are the contents: heat engine, cycle, heat engine and refrigerator. So friends, nowadays power, I mean mechanical power and cooling by refrigeration, these are the essential parts of our daily life as well as industries. When we talk about the motorcycle, car or aeroplane, then the heat engine comes in picture. So we should know about the heat engine. Then firstly we should know about the heat engine cycle, because heat engine is nothing but a engine, such engine which works on a heat engine cycle. Now the heat engine cycle is such a thermodynamic cycle in which there is a net heat transfer to the system and there is a net work transfer from the system. It means simply we can say heat engine nothing but this is the thermodynamic device in which heat energy converts into mechanical energy. This is the heat engine. We can say this from this particular block diagram. Now in this block diagram there are three parts which are very important. First one is the source, another is the sink, and this is the thermodynamic cycle which works on a heat engine cycle, that is the heat engine. Now we can see from this block diagram, these are the two thermal energy reservoir. Now the thermal energy reservoir is a reservoir with infinite heat capacity. It means for the source T1, which is at always high temperature, it means T1 is always greater than T2. It means if we can take any amount of heat from this reservoir, then the temperature of this reservoir cannot be changed. It means does not change of the temperature. If at the same time, if sink, we added any amount of heat to this particular thermal energy reservoir, then the temperature of the sink does not change. Now these are the thermal energy reservoir. In heat engine, there is a net heat transfer to the heat engine. Now Q1 is a heat supplied, which supplied to the heat engine by utilization of some portion of this particular heat energy. Some part of the Q1 can be converted into W net, which is a net work done. But the whole heat energy cannot be converted into work done, because heat is a low grade energy and work is a high grade energy. There is a limitation. This is the limitation. We are know about these things with the by Newton's second law. So then Q1 is some part of the Q1 converted into W net. Q2, which cannot be converted into work done, that part rejected to the sink. Now the question is that how good is this particular heat engine? So we can measure the goodness of this particular heat engine by the efficiency, which is a efficiency. Okay, efficiency is nothing but this is the output to the input. So what will be the output in this particular heat engine? W net is the output. So and the input is the heat supplied, which is Q1. Now this is the heat supplied. This is the heat supplied and this is the work done. Now this is the thermal efficiency. It means if we get more work done, then the efficiency of the engine will be more. So now I conclude my lecture. Today I cover the topic heat engine cycle, heat engine. Now in next lecture I will cover the refrigerator.